Hello friends, this is one interesting video in which there was an intumescent cataract, mature cataract, but a very hard nucleus. So as it is advisable that in these situations is to prevent the ripping of the anterior capsule during rhexis and producing a Argentina flag sign, a smaller rhexis should be attempted just to have some time to decompress the increased intralenticular pressure. Here we can see just the nicking the capsule release some amount of fluid, although the stained capsule and a small nick in the capsule didn't allow any progression of the initial cut. So here I am making a very small rhexis just to allow the burping of the retained fluid and pressure. Going ahead with the cannula on a syringe, aspirating out whatever I could, but this could cause some hypotony in the anterior chamber. Now we are proceeding for making the standard size rhexis. So instilling some viscoelastic material to reform the anterior chamber and performing a nick in the capsule using a 1/2 scissor. Propagating the rhexis so that it is of adequate size now, and as you can see it is smoothly moving with no outward spiraling of the capsular tag. It's important to grasp and re-grasp as the rhexis progresses. It is possible in particular angles that the forceps has difficulty in grasping the end of the capsule, so one has to maneuver and make sure that the capsular tag is gripped properly so that the rhexis doesn't extend out. This is the portion where we are disassembling the nucleus. It's a hard nucleus and a bulky one. I use a burst mode for these situations so as to get the maximum possible purchase by 1 or 2 bursts, and then applying my horizontal chopper at the equator of the lens so as to compress it again more so as I get a good purchase. If the purchase or the penetration of the phaco tip is something like more than 50% of the depth, you get a nice crack which is through and through in first go, which is so very relieving if you have a first crack which is full thickness in such a cataract. At times there are these hard inside cores which, if separated out, can be emulsified before proceeding for taking out the outer core. Separating the posterior limit of the connected nuclear chunk. This part of the video is in twice the speed, so as just to make the video shorter while retaining all the key elements. If the posterior limit of the nuclear elements is properly separated, then these pieces will simply can be pulled out for emulsification. The emulsification is being done at the pupillary plane, as these capsules are not very elastic and very fragile, so every care should be taken not to stretch the capsular back too much. Half of the nucleus has been emulsified, and this is now important thing which I want to demonstrate, that the nuclear pieces can be disassembled from any particular side or plane, whichever is feasible for capturing using the phaco tip. Larger pieces can be chopped and re-chopped again and again, make it facilitating for the phaco probe to consume them. The nucleus has by this time been flipped upside down. That makes it a little easy because now the remaining depth can be punctured from this side and you get a better groove. Now the last quadrant is being emulsified, and this moment it's important to reduce the aspiration flow and vacuum. If you keep your settings at linear, then lifting the foot pad little bit up will help in removing this piece of last fragment, which may cause sudden collapse of the chamber, and bare PC may come and be in contact with the phaco tip, causing a PC tear. So it's better to reduce the aspiration flow if you have a machine setting which allows you to do so by altering the pressing of the foot switch. Proceeding for IOL implantation, there is hardly any cortex, as is commonly seen in these large dense nuclei. Most of the amount of manipulation which is done during the disassembly and consummation of the nucleus usually results into dislodgement of most of the cortex.